So this is another set of 5 amount of substance questions, all multiple choice, all from AQA A-level chemistry. I'm going to recommend that you pause on each question, have a go at this for yourself and check if you're working along the right lines. So with that in mind, let's look at question 1. And in this, we have got a percentage yield question, but there is a lot more to it than just percentage yield. We actually have to go through a full reacting masses question first. So let's start off by drawing out the table. We identify the species that we are interested in, that we want to know the mass of, and what we have the mass of. And bear in mind, although there's 2 masses here, one is what we've started with and one is what we've ended up with. We're going to find out the maximum theoretical mass of ethanol so we can do percentage yield. So let's put our M, MR, N and ratio in, and now let's start to populate this table. We have been given a mass of glucose that we started with. It was 1.44 kilograms. We need to convert that into grams, so 1440. And we've been given its MR. We could have had to calculate it, but it's been done for you, 180. And if I have M and MR, I can calculate N, and we find out it's quite a nice round number. We have 8 moles of glucose. Now from the equation we can see that 1 mole of glucose makes 2 moles of ethanol. We have our mole ratio 1 to 2. And if we know that 1 mole makes 2 moles, we know that 8 moles makes 16 moles. Now if I know that it's 16 moles and I've been given the MR of 46 within the question, I can then multiply the N and the MR together to find my maximum theoretical mass. And it comes to 736 grams. Now we finally get to the percentage yield. We should have made 736 grams, but we only made 268. So what is 268 as a percentage of 736? We do the calculation and we find it comes to 36.4%. The correct answer is B. Next question for you to have a look at. And with this one, we are having to think again about number of moles. We've been given a mass. So let's find out how many moles of propane. N is M over MR. Now the mass has been given in kilograms. We will want it in grams. So we do that conversion, 5,000. And we can find the MR of propane, C3H8. You'd be expected to know that formula, but you've got the periodic table to find that that's 3 12s and 8 1s, giving us a relative molecular mass of 44. I now do the division. 5,000 over 44 gives me 113.64 moles of propane. I don't want the number of moles, I want the number of molecules. So I'm going to multiply the number of moles by Avogadro's number. I do that and it takes me to 6.8 by 10 to the 25. The correct answer is C. On to the next question here for you to have a think about. And this relies on you remembering that density is mass over volume. You're wanting to know the volume in each case, so let's rearrange it. Volume is mass over density. And then I'm simply going to go through and do mass over density in each of the 4 cases. For A, I've got 0.5 grams. Remember to do that conversion. And I'm dividing by 0.63. That's 0.794 as the volume. On to the next one for part B. I'm converting my mass again. 650 milligrams is 0.65 grams. Divide by 0.8. On this one, my volume is 0.8125. On to my third, I don't have to do conversion of masses now. So it's 1.2 grams. I do 1.2 divided by 1.33, giving me a volume of 0.902. And my final one, when I do exactly the same, 1.3 over 1.48, I get 0.88. With all of that in mind, I simply now have to identify the biggest value, which is 0.902. The correct answer is C. Moving on to the next question for you to try now. So on this one, we've got a mass of anhydrous sodium sulfate. We need to know the formula for sodium sulfate here. And then we can do our mole calculation. So N is M over MR. So the M is 4.85. We have to know that sulfate has a charge of -2. Sodium has a charge of +1. So its formula is Na2SO4. That allows us to work out our molecular mass of 142.1. And once we've got our M and our MR and we do the division, we find that we've got 0.0341 moles of sodium sulfate. But we're not finished yet, because that number of moles was dissolved in 250 centimetre cubed of water. So if we want concentration, we need to do moles divided by volume. You'll see here my 250 cm cubed has been converted into dm cubed. I've divided by 1,000 because my concentration is in moles per decimetre cubed. That takes me to 0.137 mole dm to the -3. Correct answer is B. On to the next question now. Have a go, see what you can do with this. Now on the first one, we have got a mass. We actually want to know the number of atoms, but let's deal with the number of molecules first. So I've converted my 127 milligrams into grams. I am dividing that by the 2 times 126.9. That's my MR of iodine. It means I've got 5 by 10 to the -4 moles of I2. But I want to know atoms. So within my diatomic molecules, I've got 2 iodine atoms for every molecule. I multiply that together and it means I've got 1 by 10 to the -3 atoms within that sample. When I move on to the next one, I do the same thing again. I've got to do my conversion, which is a little bit fiddly. 1.5 by 10 to the -4 kilograms, but in grams. So it's 1.5 by 10 to the -4 multiplied by 1,000, which is 0.154. And phosphorus has an MR of 31. Now that takes me to 5 by 10 to the -3 moles. A higher number, but we've still got more to investigate. The next one, 81 milligrams of carbon dioxide. Again, we've got to remember to convert our milligrams into grams. So 0.081, and we're multiplying that by 44. And that takes us to 1.8 by 10 to the -3 moles of carbon dioxide. I'm going to come back and talk about that one in a second as well, once I get to the end of the answer. When I get to D, we have got 1.7 by 10 to the -4 kilograms. Let's convert that into grams, 0.17, and let's divide by the MR, which is 17. That's 0.01 moles. Now, if I take a look at all of those, my number of moles here is clearly the highest in ammonia, but we've not quite finished yet. And I'm going to show you what you need to do with ammonia, because one ammonia molecule is 4 atoms. So just as we did with iodine, I'm going to multiply this answer by 4. I have 0.04 moles. Now with the CO2, you would need to multiply the 1.8 by 10 to the -3 by 3, because there's 1 carbon and 2 oxygens. Phosphorus, arguably, based on your knowledge of the melting point trend, you could multiply 5 by 10 to the -3 by 4 to the P4 molecule. That would be immaterial because it's still lower than the value we have for ammonia. The correct answer is D. And that takes us to the end of this selection of questions. Thank you for listening and goodbye.